Hello everyone, welcome to Canal Physics. Today we are looking at dimensional analysis. So what is dimensional analysis? It is basically used to determine the dimensions or units of a derived quantity. And the way we show dimensions of a quantity is by putting square brackets around it. So square brackets around a certain quantity, and we put the symbol for the quantity here. That means the dimensions of the quantity. The most common ones we will use are for length, mass, and time. As we know from the previous video, the units or the SI unit for length is the meter, for mass kilograms, and time seconds. But to do dimensional analysis, it's slightly different, and we use a capital L for length, capital M for mass, capital T for time. So let's put this into practice for something that we should know already, and this is area. So if we consider the area of a square with side length L, that would be A equals L squared. So this is the formula for the area of a square. So to find the dimensions of area, we write it like this. We write the formula in square brackets, each symbol in square brackets. And now actually writing the dimensions, that is L squared. So the dimensions of area is L squared. Let's do this for another shape, the triangle. So if we have the base being B and the height being H, this is the area of a triangle, A equals half base times height. So when we have constants in a formula, those do not contribute to the dimensions. So we can leave that out when we do the next line. So dimensions of area equals dimensions of B times dimensions of H. And since B and H are basically just lengths, we can write L times L. So as we'd expect, this would be the exact same as for the area of a rectangle, or square, because whether it's a square, rectangle, or triangle, or any shape, area will have the same dimensions. But using the language of units, you'd be familiar with square meters. So these are both, for the unit equivalent is square meters, but dimensions is L squared. Let's do an example. So this example is asking us to determine the dimensions of density, which has a symbol Greek letter rho. So first we need to know the formula for density, and from the previous video, it is mass divided by volume, so lowercase m for mass, capital V for volume. So this is the formula for density. So to do dimensional analysis, we put everything in square brackets. So the dimensions of density equal the dimensions of mass divided by the dimensions of volume. But we need to make sure everything is in terms of the fundamental dimensions. Mass is fine, that's just capital M, but we need to make sure volume becomes fundamental. So we'll leave mass because that's fine, but volume is a length value cubed. So we'll just use lowercase l for the length. We can just assume the 3D shape is a cube because the dimensions will be the same regardless, no matter what shape it is. So now that we have our fundamental quantities, we can write the dimensions. So mass is capital M from our table in the previous page, and the denominator L cubed, that is dimensions capital L cubed. Now in physics, we don't usually leave our final answer as a fraction. We write it in index form, so we can bring that L cubed to the top, and it can be written as ml negative 3. And these are the dimensions of density. And just as a side note, the SI unit equivalent for this is kilograms per cubic meter. Let's do a more interesting example. So I'll just read it out. The period of a pendulum, capital T, is the time it takes for one complete swing. So for a pendulum, that means from the release point, which let's say is here on the left, the time it takes to go there and back is the period. And the formula for the period of a pendulum is 2 pi times the square root of L over G, where L is the length of the pendulum and G equals 9.8 meters per square second. So the length of the pendulum is just this length here. And this value of G, this is just the acceleration due to Earth's gravity. You don't need to know exactly what this means at this stage, but you do need to take note of these units. And these are the SI units, meters and seconds. So the question is asking to show that the period has the same dimensions as time. And we should expect this because the question is saying that the period of a pendulum is simply the time it takes for one complete swing of the pendulum. So we'd expect period to be measured in seconds. So we'd expect the dimensions of period to be capital T. And I'm not referring to this capital T, the symbol for the period. It's just coincidentally the same symbol. I'm talking about the capital T from the previous pages, the dimension for time. Now, because we're going to see some double up symbols, I am going to try and write as best I can italics and not italics when appropriate. So as discussed, the 2 pi is a constant, so that does not contribute to the dimensions because it doesn't have any dimensions of its own. So the dimensions of the period equals the square root of the dimensions of the length over the dimensions of G. So now we can write the dimensions. So the square root of the dimensions of length, which is L, over the dimensions of G. So we must look at the units here, meters per second squared. So the dimension equivalent for the unit meter is capital L, length, same as the numerator. And for seconds, time, that dimension is capital T for time. And we must not forget the power as well, the -2. Now the length dimension cancels, which simplifies to 1 over t to the power of -2, and bringing t to the power of -2 to the top, that becomes t squared. Don't forget that square root, and that is just t. The square root of a square is just the original value. So as required, the dimensions of period are the same as time. So don't be confused with the double symbols. So in our working, we had capital L for dimension length, the dimension of length. But here is the italicized capital L for the symbol for length, which is from the formula, so they're different. And same for period. Just coincidentally, capital T is used for period. The same symbol is used for the dimension of time. So I tried to draw and write an italicized capital T here for the quantity symbol. But for dimensions and units, as discussed in the previous video, we do not italicize units and we don't italicize dimensions as well. And just as a side note, the equivalent SI unit for this is seconds. Thank you for watching this video. If you found it helpful, please like and share it and subscribe to my channel for more.